All right, welcome back. And today we are going to do a question called shortest unique prefix. So let's read the question. Given a list of words, like for example here, for each word, find the shortest unique prefix. You can assume a word will not be a substring of another word. So there's a few things to unpack here. First of all, what is a prefix? Prefix means the first few letters of a string, I guess. And then the shortest unique prefix. So what does that mean? So that means for each word, as you can see for Joma, the shortest prefix is J-O-M. Why? Because like what we want to do is we want to have it such that it's unique. We can't do J because John also starts with J. We can't do J-O because John also starts with J-O, right? J-O-M, finally, nobody has the prefix J-O-M. So that's the shortest, J-O-M. Same thing with John, J, I can't do that because Jack is also starts with J. J-O, I can't do that because J-O is in Joma. And then finally, J-O-H is unique in the prefix within all of these guys. Right? And then for example, tech lead, we can just simply do T because none of the other words starts with T. So this is basically the shortest unique prefix of all of these words, right? So that's how you do it. Now, if you've done a lot of Leetcode or like just in general algorithm questions, this should be pretty obvious to you in terms of what you should use. You should use a trie, T-R-I-E. Usually when you're thinking about prefixes or strings and stuff like that, then you have to use a trie. What is a trie and how do you use it? A trie basically is a tree, and then for each children, it's kind of like a letter, right? And let me show you actually. Let's go through this example. Let's construct this trie and then I'll tell you why it's useful. So what the trie can do is it can help us determine, given these words, how many words have we passed into certain letters so far. And then we're going to be using these nodes as references to if we can use it as a prefix, as a unique prefix. I'll do it a little bit more clearly once I do it. So, all right, let's look at this. So first, let's insert Joma into our trie. So first we have an empty trie. So this is just an empty node. And then we have J, okay? We have J. And then now we have this node. This string is J. This is the J node, right? And then this can also have T because we're gonna have tech lead, but I'm just doing Joma for now, so I'm not gonna show you what this is yet. So we have J, and then now we have this node that's J, and then we have 1. We're gonna say 1 here, okay? Because we passed through it once, okay? And then we continue with O because we're doing Joma right now, right? So then O. And then now this node is J-O, right? And then the count is 1 still. We don't actually need to have these strings in our nodes, but it's just mostly to show you guys what's going on. Here we're gonna have M, and then so we have J-O-M, and then finally we have A, which is J-O-M-A, J-O-M-A for Joma, and we have 1 of them. Okay, cool. Now let's go back. So now that we're done with Joma, we're gonna do John now. Okay, so John also starts with J. So because we already have a node here, we're just gonna add 1 to this guy. So now it becomes 2. All right, and then for John, J-O, so then the next one is also O. So we're gonna go all the way here, and then instead of 1 now, it's gonna become 2. All right, and then finally it diverges because John is J-O-H, so then this is gonna be H, and then this is gonna be J-O-H, and then we're gonna have 1 value here. And then if we go down, we're gonna have N, so we're gonna have John, and then we're gonna have the value 1. All right, cool. Now let's do Jack. Let's do this guy now. So J, once again, it's gonna be is gonna start with a J. So do you kind of understand what try here is for? So these nodes kind of tell you how many words go through this node, or how many words starts with J, and then how many words starts with J-O, right? 2, because it's written here, right? Anyways, let's continue. So A for Ja, so then we got 2 here. And then for C, then we have JAC, got 1 here. Oops, I made a mistake. This guy's 1. And then finally, we got K for Jack. And then there is 1 over here. And then finally, tech lead, the great tech lead. We're gonna have T. So we're gonna have T1. And then I think you kind of get what's going on, right? It's like tech, that's gonna have 1. And then at the end, ... we're gonna get tech lead, and they're all 1s. So now, how do we use this to get the unique prefix, the unique shortest prefix? So it's actually very easy now. Now that you have the try built, what you have to do is you have to just go through, okay, so Joma, what is my unique prefix? Okay, so let's just go through the tree. So it starts with J, and then whoop, and then what's after J? It's O. And by the way, you keep going until you see a 1. You see a 2, and then what's after O? It's M for Joma, and then, oh, finally, I got it, J-O-M. So J-O-M will be the answer. All right, let's try John now. So John, it starts with J also. All right. And then what's after J? It's O also. Okay. Is it a 1 yet? No, it's still not a 1. Okay. What's after O? It's H. Oh, it is a 1 now. Perfect. J-O-H. Okay, J-O-H. That's the unique, shortest unique prefix. Now let's do Jack. We'll do red. Okay, J. Okay, it starts with J. Perfect. And then after J, it becomes A. Okay, perfect. Ooh, this is a 1 already. Excellent. So J-A, that's our answer. J-A. And then finally, let's do tech lead. We'll use purple, the color of royalty. And then it starts with a T. Okay, T. Oh my God, it's already a 1. So that's the unique prefix. So these rainbow colors, this is basically the answer. That is your output. Output. Yeah, so that's pretty much it. That's how you solve this question. And yeah, we could go back and look at it. Whoa, beautiful. Okay, so what is the time complexity of this? Well, the time complexity of this, first of all, you have to build the try. So building the try will be oven, because you have to go through all the words, and then through all the words, you have to build the tree. So that's oven. And then later on, you're gonna have to retrieve it also, and you have to go through all the words also, which is also oven, you know, like what we just did so far with the colors. In terms of space, we need oven, because to create this try, you need oven space, linear space to how many words there are. So that's pretty much it. All right, cool. So that's pretty much it for that. Now let's code it. Coding it is a little bit difficult unless you've coded tries before, but I think it's worth, I wouldn't say memorizing, but practicing a few times building tries, because it's definitely worth it. So okay, so in a try, let's do this. In a try, we need nodes, because each of these node is a each of these stops are a node, and then a try is basically the root of a node. Kind of like a binary search tree, right? And a tree is just a node. Okay, so first we got a node. All right, okay. I'm not gonna explain this because usually these are like boilerplate code, and it's pretty. Oh, but instead the only difference is that we have a count of 0 here because we care about the count, and also we have the children, which will have like a dictionary, or it could be a dictionary here. All right, and then we're gonna have the class try. Okay, And then what it is we just have the root pointing to a node. So we just have a try right here. Spelled it wrong. Okay. All right. So now that we have a try, then we're going to add some functions to it so that it makes it a lot easier. So we're going to do insert. So this is the same thing when I showed you doing the whole me building my try, like using one word. So we give a word and then we're going to start building the try. I really hope I'm saying try right, because maybe some people say tree, but I'll say try. Okay. All right. So insert. So what we're going to do is first we have our current node. All right, perfect, right here. And then what we're going to do is we're going to loop through the characters in the word. And then what we're going to do is we're going to see if on our current node, if there's a child that is C. All right, so C not in current node children. So that means if there's no children that is related to the character that I want to see, then I'm going to create this node. Kind of like when you saw Joma, for the first one, for the first word, you're going to be creating nodes all the time because you haven't added any words into your try yet. So current node dot children C, and then you create this new node for yourself. All right, and then no matter what, after, what you want to do is you want to go through the children, right? So when we go down to try, we're going to go to the children. So that's why we're going to replace current node by the children. And then also we're going to add 1 to the counter, because each time you go through the node, you want to add 1, because that basically tells you how many words have gone through that node, which will be important for calculating the unique prefix. So that's pretty much for insert. And then the next part is unique prefix. So remember when we did all the colorful things, this is what we're going to be defining right now, unique prefix. So given a word, I want to know what is its unique prefix. All right, so first we're going to initialize our current node. We're going to go to the root again. And then we also want the prefix, which is what we're going to return in this function. So then same thing, we're going to go through all the character in that word for C in word. And then what we're going to do is if we see that the current node is 1, then that's great. We're going to return the prefix, right? Because like we saw before, if you remember, we go through the node, and then if we see a 1, then we just return it. Okay. But then if it's not, then we just keep going. So we keep going by going to the children. Yeah. All right. And then we add the character because we're constructing the prefix. All right. And then after that, you just return the prefix after you've prefix. All right. Perfect. So this is usually if it's like a substring of another string, it should not happen technically, but oh well, we never know. Okay, so all right. So then yeah, I think that's actually pretty much it. And then now that we have the try, we just need to use it. So for our function, let's define the try, and then we're just gonna insert every word into the try for word in words. Try insert word, and then we're going to return this array. We'll call it unique prefixes or pref. So it's an array. So for example, that's what we want to output, right? So cool. We loop through the words again, and then what we're going to do is we're going to do the unique prefix. We're going to append to the array, and then what are we going to append? We're going to call the function that we wrote called unique prefix. All right, and then we put our word in there, and then yeah, I think that's pretty much it. And then after that, we just have to return the array for the answer. Let's see if it works. All right, excellent, that works. Excellent. So let's do another example, see if it works. So for example, if this is JOK, then what we're gonna see is JOM, JOH, and JOK, and then technically it is just T. Right, so we're probably gonna see JOK. All right, let's see if that's true. All right, that's exactly true. All right, cool. yeah, so that's pretty much it. So I hope you learned a lot from this exercise. I actually really like this question. I think tries are pretty cool. And yeah, I hope you like them too. And see you next time.